Okay, so by using a moment calculation, we were able to find out that the reaction at right vertical is 928.95. Now that we've got that going, we can actually start working out what the calculation is here, which is reaction left vertical and reaction left horizontal. Let's just stick with the horizontal for 1 second. Basically, we're summing forces. So what we're looking for are the forces that are working in a horizontal manner on this bridge. At the moment, for this equation, there is none. So basically, the reaction then comes in on the horizontal as being a 0. There's no tricks here, but you do need to actually recognize and have a look to see if there are any in play. Depending on the question, it might actually say that there's reaction forces happening due to the truck moving. So there could be frictional forces in play here, which makes some horizontal forces in play. But for this equation, for what we can see, there are none here at the moment. So that leaves us one more to find out, and that is the reaction at left vertical. Okay, so in this case here, I'm going to use the formula. The sum of all forces equals 0. Now, same with the moments. I need to nominate a direction as being positive and negative. And by doing this, it can allow me to actually work out what I have to do with these forces. So in this case, I'm going to say all positive forces are the ones that are going in an upward direction. Now you can see what that means is every force that is going up is going to be positive. Every force that is coming down is going to be a negative. So now I can start working this out. Therefore, 0 is going to equal the positive reaction at left vertical minus a 314 because that's coming in a downward direction minus 554 because that's also in a downward direction minus 1099, and then I've got my reaction at right, which is going up, which is a positive 982. Oh, I did that wrong. My goodness. Let me just come back and let me get this right. 928.95 kilonewtons. I'm going to move this over, so I now go from a positive to a negative RLV, which then equals minus 314 minus 554 minus 1099 plus 928.95. Quite a straightforward little calculation that we can do here, and if I would have plugged that into my calculator, I would have found out that minus RLV will equal minus 1038.5. These cancel out, so RLV will equal 1038.5 kilonewtons. Okay, so you can see here, like the math is actually really quite simple. However, the problem with engineering is seeing what math needs to be done. Now that I've got all those in play, I can start looking at doing things like shear force diagrams, bending moment diagrams, and it's all of these small steps that we can take as we're progressing along in the calculating the forces within our bridge.